2.5, proving statements about segments. So a lot of these are going to be obviously proof. Some of them they're giving us the stuff. Some of us they're not, or some of them they're not. We're going to have to like fill them in. So we won't be doing as many examples. It's not going to feel like, but it's still probably going to take us just about as long just because of the nature of the problems taking longer. So number 6, this is the reflexive property. Thank you. Of segment congruence. So they tell us that the given is that EF is a line segment. And they want us to prove that segment EF is congruent to segment EF. And they show you a picture of a segment. Not really necessary, but they give it to us anyways. All right, now this one, they're really just wanting us to, they actually, well, let me just show you. They give us a proof and we're filling in the blanks, basically. So we've got statements on one side and reasons on the other. The first thing they tell us is that EF is equal to EF. And we're going to be filling in this blank here. And then over here, we're going to fill in this blank. And the reason is definition of congruent segments. So in ordinary situations, okay, you would need to write the given as your first step. Because you're just filling in the blanks, we're not worrying about that, okay? But as a general rule, anytime we're doing anything, we're going to write the given statement first. So in my opinion, this should really be 2, this should really be 3, and I should have a 1 up here where I write EF as a line segment and write given over here. But that's not how they do these ones, the first 2 problems in the book. So, the first one really. All right, so EF is equal to EF. Well, that is the reflexive property of segment congruence. So I'm going to write that. And that's a property that you should have in your book. Or I guess it's technically a reflexive property of equality. We'll just say reflexive property. That's fine. So it's pretty easy when they give you one like this. Your last thing should pretty much always be what you're trying to prove. So this statement that's going in here is literally just segment EF is congruent to segment EF. No, they're not going to all be that easy or just like a give me problem, but some of them are. All right, number 8. These say to solve for the variable using the given information, explain your steps. So if you see something like that, that means you're writing a proof, okay? Because otherwise, we could just take this and we could solve this without ever writing any reasons down. But they want us to explain, so that means we're going to set up a proof. So for number 8, the given information is that segment AB is congruent to segment BC, and then that segment CD is congruent to segment BC. And then they show us, basically, they have a line segment here, with A, B, C, and D on it going across. And AB has an equation 2x plus 1. CD is 4x minus 11. All right, so they aren't telling us what we're trying to prove in the actual problem statement, but in the instructions they say to solve for the variable. So I know that ultimately my final step should be an x equals something, okay? So I'm going to set up my proof. So my statements are going on this side, and my reasons are going over here. All right, so the first thing we always write down are our givens. If you want to write them on two separate lines, that's fine. If you want to write them on one line, that's also fine. I like to save as much room on my paper as possible, so I'm going to write them on one and just put a comma between the two things, basically like it was given to me up top. And the reason we want to number our statement and our reason is because sometimes your reason, depending on how big you write, may end up going on to a second line, and sometimes your statement goes on to a second line, depending on what we're proving at the time. So we want to make sure that we number the things so that if our lines aren't side by side, we can still match up what's going on. So the reason for this is that it is a given. So the next thing I would look at is that, well, I've got AB is congruent to BC and I've got CD is congruent to BC. Well, both of these have a BC in them, so that would tell me then that I can say that AB is congruent to CD. So step 2 is going to be AB is congruent to CD. Anybody know the reason for that? It's one of our properties. Yep, transitive property. So this is the transitive property of segment congruence. So what you're going to pretty much always notice is anytime that I have segments listed as being congruent, depending on what I'm trying to find, I'm going to end up then rewriting something like AB is equal to CD. And your reason for that is going to be the definition of congruent segments. And you've probably figured this out by now, but I abbreviate definition as either just DEF or DEF with a little n because that's what my professors all did in college. If you want to write the word out, that's also fine. All right, so now I've gotten to this point. Well, I know what AB is equal to, and I know what CD is equal to, so I can replace those things. So I'm going to have 2x plus 1 is equal to 4x minus 11. Anybody know what allows me to do that? Starts with an S.
Substitution.
Yep, substitution. All right, now, there are a lot of times in math where we do steps kind of simultaneously, okay? We have to be really, really careful about doing that in geometry because of the reasons behind it, okay? So this problem is one where I can subtract my 4x over here and I can subtract the 1 over here. And I can do those at the same time in this particular problem because they're both subtracting, okay? If this was a minus 1 over here and I needed to add it over, I would have to wait and do that in its own step because that's a whole different reason behind why I'm allowed to do that, okay? So that's where, for some of you, it's probably going to get a little bit annoying because you're like, I can do this at the same time. And it's like, well, yes, I understand that. Believe me, it's annoying to me as well. But we have to put that reason down. And so we're going to have to list them out individually. Okay? So in this step, I'm going to subtract 4x. So that's going to give me a negative 2x. And I'm also going to subtract the 1 at the same time. So this is going to be equal to negative 12. And I can do this by the subtraction property. If you want to write it out as two separate things, you can also do that instead. You'll just end up with one more step in your proof than everyone else, but that's fine. All right, now I'm going to divide by my negative 2. So that's going to give me that x is equal to positive 6. And I can do that by the division property. And then I'm done. So I have solved out what they wanted me to solve for. Questions on that one? Because I know there's a lot happening. Okay. All right, next problem. Same instructions. We are given that segment ST is congruent to segment SR, and that segment QR is congruent to segment SR. Now my picture for this one's a little bit different. It's like a line over from Q to R. Then it goes up at an angle from R to S. Then it goes over as a straight line from S to T. And Q to R is x plus 4, and S to T is 5 times 3x minus 2. All right, so I'm going to set up my proof. So I got my statements. I've got my reasons. All right, so what's my first thing always going to be?
The given.
Right, the given. So that's going to be ST is congruent to SR, both of those being segments. And then I'm going to put a comma, QR is congruent to SR. And again, if you want to write them as two separate things, you would just write 1 and 2, and then you'd write given under both 1 and 2. But we can do it all as one. So that's the given. All right, so kind of based on what I did in the last one, any guesses as to what my next step might be?
ST is congruent to QR.
Yep, and why can we do that?
Transitive property of segment congruence.
Yep. Transitive property. Ideas on what my next step will be? What's pretty much always the step that's going to follow this? Nope. Yep, ST equals QR, so we're going to change them so that they're just equal to each other. And what's my reason for that?
Definition of congruent segments.
Yep, definition of congruent segments. So obviously things that are like definitions, you're going to have to just know, right? But the stuff that's like theorems and postulates and properties and things like that, those should all have been in your theorem and postulate book, okay? Which is what's going to help you as you go through these problems. You're not just expected to memorize everything. Some teachers do expect you to memorize everything. I think that's wild, so I don't make you do that. But that's why we have that book. You're going to grow to appreciate that book more and more as we go through the next few chapters, okay? All right, next thing. I can replace ST and QR with the problems up here by substitution. So I've got 5 times 3x minus 2 equals x plus 4. What allows me to do that? Substitution.
Is it okay if we like flip flop them, or does it have to be the same?
They need to go this way because it needs to be what lines up with this from like what the step before was. Now, up here, I technically could have written QR as congruent to ST and then had QRs equal to ST, but since I have it in this order, this is the way that I have to keep it. But if you had flipped them, it would be, you'll get the same answer and it would be fine. You just have to stay consistent all the way down. All right. Ideas on what I would do first? As far as just like solving it? Distribute. So it's 15x minus 10 equals x plus 4. And that would just be the distributive property. And also, there's nothing that says that I can't solve this all the way down and go back and write my reasons after. If you feel like you're going to get confused by like bouncing back and forth between the things, you could solve the entire equation down and then go back and write your reasons. Just remember, if you do 2 different types of things in the same step, you're going to have to go back and change it because we can't do that. All right, what would I do next? Okay, so I could either add the 10 first or I could subtract the x first, but I cannot do them at the same time because of they're not being the same thing. Okay, so it doesn't matter which order we do them in, so steps 6 and 7 could be swapped. So I'm going to subtract x first, but it does not matter. So subtracting x, I get 14x minus 10 equals 4. And this is going to drive me insane. Turn this off. That would be subtraction property. Next step, now I can add the 10 over. So 14x is equal to 14. And that would be the addition property. And what would be my last thing? Yep. So I'd get x is equal to 1, and that's done by the division property. So again, step 6 and 7 could have been swapped here, and it would have been totally fine. The order does not matter in this particular problem. Huh? The more you do, the easier it will be. Okay? The more problems that you do and work through, it'll get easier. All right. $16. So this is one where they're going to give you a problem. They're going to set up a proof for you. What they're telling us is that the statements are in the correct order. The reasons are not. So we need to put them in the right order. Okay? But most of you don't have your book open. A few of you do. So we're going to go through and we're going to try to just figure out what it is without looking at them. If you want to open your book, that's fine. But we don't have to. All right. So problem 16 tells us the givens are UV is congruent to XY. VW is congruent to WX. All these are segments, obviously. WX is congruent to YZ. We're trying to prove that UW is congruent to XZ. And they give us a picture. It's a huge line segment. And it goes all the way from U to Z.
Is that VW or
U, V, W, X, Y, Z. Just in order of the alphabet. Alright, so I'm going to set up the problem here the way that they're giving it to us. I'm just not going to fill in the reasons yet. So, statement, reasons. So again, they've given you the statements in order. We're going to be filling in the reasons. So the first statement is UV is congruent to XY. VW is congruent to WX. WX is congruent to YZ. Statement 2, VW is congruent to YZ. 3, UV is equal to XY and VW is equal to YZ. 4, UV plus VW is equal to XY plus YZ. 5 is again going to have two parts. UV plus VW is equal to UW. And I'm going to go on to a second line, but it's still all statement 5. XY plus YZ is equal to XZ. Statement 6. UW is equal to XZ. And then 7, UW is congruent to XZ. Oh, yeah. All right. Ideas. What would be the reason for my first statement? Yep, it's a given. How about 2?
Transitive properties that we consider.
Yep, transitive property of segment congruence. What about 3? Yep, definition of congruent segment. So they're taking the given and they're writing those out. What about 4? Nope.
Segment addition.
Nope. Not yet. Nope. It's just addition. Addition property of equality. Now, obviously, the different options would be in front of you. If your book is open, you'd see what your options are. But how about 5? Yep, segment addition postulate. What about 6? What?
Is this one simplified?
Nope. None of the options in this one are simplify. Look at how we get from 5 to 6. What did they do?
They, combine like terms.
Subtract.
Starts with an S, but not subtract.
Substitution.
Yep, substitution. And the last thing, how do I get from 6 to 7? And a reason could repeat itself.
Is it definition of congruence?
Yep, definition of congruent segments. All right, another proof here. Number 18. They tell us that our given is that NK is congruent to NL and that NK is equal to 13. They want us to prove that NL is equal to 13. All right, so there is a picture that goes with this. It's basically a rectangle with like crossbars in it, but it's not really important for this. So we're going to write a proof to get from the given to what we're trying to prove. So my 2-column proof, set up my statements and my reasons. What's my first step always going to be?
Write the given.
Write all the given stuff. So NK is congruent to NL. And I would put a comma. NK is equal to 13. And our reason is that that's a given. Ideas on what step 2 should be if I'm trying to get to show that NL is equal to 13. Or what is often my next step when that's my first or my step prior.
NK is equal to NL.
Yep, NK equals NL. And what's the reason on that?
Transitive property of segment congruence.
It's the definition of congruent segments.
Yep, definition of congruent segments. And my last step. Ideas?
Substitution.
Yep, NL is equal to 13, or we can say 13 is equal to NL, it doesn't matter. And I can do that by substitution because I knew that NK was 13, so if that was replaced with 13, then that means NL also has to be 13.
For every time we have to write segment or congruent segment or segment or congruence or something, can we like shorten them?
As long as it's something that makes sense, yes, that's fine.
So like CONG for congruent.
Yeah, that's fine. All right, last problem is not a proof. We're close to the bell, but I'm going to try to get this one in because you're going to have problems to do this weekend because we don't have school tomorrow. All right, in the figure shown below, WX is congruent to YZ. What is the length of XZ? Do this way. And we've got a segment here. W, X, Y, and Z. W to X is 3X minus 8. This is 4X plus 15, and then this is 2X plus 3. All right, so I know that WX has to be equal to YZ, so I'm going to set those up to be equal to each other. Again, this is not a proof. This one is just solving. I'm going to add 8 and subtract 2X, so I have X is equal to 11. So now I need to plug that in for XY. So XY is going to be 4 times 11 plus 15. So that ends up being 44 plus 15. Don't go anywhere. I'm going to give you problems. 44 plus 15 is 59. Then I would need to also plug in for YZ. So I'm going to show you that really quick. So that would be 2 times 11 plus 3. 22 plus 3 is going to be 25. And finally, to get XZ, I would have XY plus YZ. And that's going to be 59 plus 25, which is 84. And this was a multiple choice question where the answer was E, but I only care about the number. All right, problems. Suggest you write these down because these will be due on Monday. 7, 9, 11, 17, and 21. So it's not a lot, but remember they're proofs. And don't forget your projects are due Monday. If you do not turn it in at the start of class on Monday, you automatically drop to a 50 because a late grade on a project is 50%. So you've had a whole week and you've had basically 2 days in class to do it. Yes.
Do we have homework